I'll send myself over to your screen in just a second. Yeah. I'm gonna make sure I'm not just screen recording my camera this time. That'd be great. Over to Canvas here. Excellent. Here's Canvas. And then I'll broadcast your screen here now. Oh, let me get off that for just a second. Okay. Should be taking over yours now. Okay. Week 8, week 7, week 8 we are. Auxiliary support. Yeah. I think I'm just going to do them in this order this week and these three that we have to do. So I'll open this one up. Not that they're all none are harder than the other per se. You could do them in any order really, but I think the only thing that's loaded on any of them is just this imagery for what the assignment is. This is the auxiliary support. So it is, yeah, an inch template looks like to me. So I'll open that up. That's a good point. Get my inch template opened up. Maybe here, templates. Whether it's A or B size, I think this one ends up being on a B size sheet. So I think I'll just open my B size template, which is this one for me right here. I think I've got it all updated, right? Yeah. So yeah, I don't think the A size is going to do me give me quite enough room unless it's quite scaled down. So excellent. Got my template open. I'll just do a little bit of study here. Um, So I'll talk through this where you don't have any other imagery for this. Let me talk through this assignment a little bit. So um and see if it gives I don't think there's not a ton, just that we have drafter's choice on which scale and drawing size. I'm pretty sure I got to fit it on a B size sheet. Um and we got to do some sectioning here to display this maybe correctly. And we'll see why pretty easily when we start the front view. So I'm definitely gonna want a front view, top right side, I'm not sure, and a section view. I didn't end up using all of those views, and let's see if we can understand maybe why before we even start here. Okay, so if I look at this, it's kind of leaning in the other direction than we've sometimes see. I feel like this one is kind of like going to my left. Normally, a lot of our imagery in isometrics is going to our right. So let me just kind of evaluate for a view. So I'll say one thing that kind of becomes really standard, and we did the Geneva cam this way, and there are some characteristics of this part that are like the Geneva cam. So the Geneva cam displayed the best if we put like the front view as maybe what would potentially, could be the top view or looking down on that Geneva cam, right? Like that's where it showed its best descriptive, like the part details and how they look. And it kind of breaks the rule a little bit of like stable part position, because if I use like in the Geneva cam, I just use that it kind of became my front view of looking at it, but technically it's not stable at all standing up. And this one is maybe a little bit more stable, but I kind of approach like a lot of cylindrical shaped parts or parts the same way I approach the Geneva cam, and that I tend to put my front view as it kind of breaks the rule of not stable part position, but it is best like most descriptive view image of the object. And so if I think of that, that's what's going to pick my front view for me here. And I feel like early in our drafting careers, that's going to be fine. There may be a time when we do need to consider more part stability and maybe draw another view that is the real front view that's stable, and then take the top view as my detail view for dimensions. And that could be done. If you're ever working in an environment where that's what they make you do, that's fine. It just depends on the work environment. A lot of times when I did cylindrical shape things, or if I think of a plate, even just detailing like the back plate of this, I'm probably not going to draw it flat, like flat and stable. Like just sitting down flat on a table would be its most stable. I'm actually going to draw it up on edge, and detail it out as almost my front view. But it breaks that rule of stability. And so anyway, just be have that in your mind a little bit that maybe we're bending the rules a little bit here. But I'm going to approach this, and in mechanical, you will detail a lot of parts like this. I have in my career a lot, round features, and I want to show these round features. I want to be able to call them out and size them where they with visible line work. So how I'm going to proceed on this one is I'm going to pick this, and I call this my X plate here. And so this kind of is shaped like an X. And then we have a kind of like a pipe or something, some feature going through here and extending through to this other rounded plate here. So I'm going to draw it with this surface of the X as my front view. Is that right? I think so. Yes. And then I'm thinking if I do that, then I take a right side view. That would put this as front, and and then I would look this way as my right side view, and I would be able to see, this surface and this surface here. My eyeballs would just be right there, looking perpendicular to that, and that's going to be my right side view. So I think I'm going to do front and right side like that. But then the top view would be identical. Yeah, it would be kind of identical to a right side view. It would be just turn 90 degrees, right? The good identification of that. If I do those, my top does nothing for me because the right side view will be exactly the same. But what I'll still lack is I will in the front view, this X plate will be in front of this plate and it will kind of bury its features. I won't be able to, it'll be like hidden behind it, and I'll show its hidden line work of this truly round plate behind here. And so it'll be coming through as hidden work here. And so I'm going to then do a right side view and then section and cut down through it pretty much halfway in between these two, where this plate and this plate. I'm only going to section this particular maybe it's a pipe or a cylindrical part of this, and then I'm going to like look at this plate. So I might be looking to my right when I section through there. I'm going to section my right side view and look to my right, and then I'm going to pull that plate and then be able to detail it. I think so. Yes. I mean, there are arguments that I could say, well, maybe I'll do a viewing plane rather than a section plane, and that might be a good choice too. So when we get there, we'll talk about through how I need to. Well, I'll at least start with the front view and then my right side view, and then just go from there, knowing that I'll still have features that are buried that I need to expose. And so we'll talk through what my options might be there. So okay, let's do that. It's also got a counterbore going on and a through. So I think through means through, all the way through. So this to me is a great candidate for also something that is else on here is a parts list. Like I feel like it's kind of three different parts. The only thing is I would maybe have needed to supply you what the materials are. And maybe in here I would have needed to call those out with like a little a balloon or something that said, hey, this is, and give you a parts list of what this is made out of. So we still aren't there yet, but this is a good candidate that, yes, it could be 3D printed. So if it was the right material, this could be a continuous part. For some other applications with other materials, it might need to be multiple parts joined together, maybe with welding or some other joinery and made out of three different parts. But that's just me. And then I'm just going to read my notes here. We got the sharp edges and burrs we need to remove. The radius features on the X plate are tangent to tangent. So all I'm trying to communicate there is that this X plate has a bunch of radius features. They are tangent to tangent, I think. So hopefully we can utilize some of our CAD's commands to get those in. So I'm gonna pull up that PDF from week 8. I should have it as my auxiliary support. So I'm gonna pull up my isometric PDF so I have it up on my other screen. And I guess before I move it over there and I'll start drawing, I'll definitely still box myself in, just making sure I capture what what this is going to fit in. This is not the right PDF. I'm going to close that one. I fixed this up a little bit better. So let me see. I probably have another one that's this one. Yeah, this one looks better. Same work, just a little bit cleaned up. Okay, so I just need some overall part size here is at least 2 by 2, but then it's beyond that by some radius of 0.625. So the way I read it, how wide this overall part is, which is always I always like to know my overalls. I mean, I'm going to dimension them too, but it helps me kind of start a construction phase here. Not that I couldn't start this with a 2 by 2 square pattern, kind of like this is 2 inch by 2 inch. I could start that pattern and then start building out from there. That would be okay. Like there's no reason I have to totally box this in. I'll just kind of keep with my format that I've been doing. But yeah, this is a radius of 5/8, 0.625. So if I need to know, 5/8 and 5/8 would be what, an inch and a quarter, plus the 2 would be 3 1/4. But if I don't know that, I can always, sorry, go over my calculator. I can stay on that other drawing, bring up my calculator. But it's going to be 5/8, 5/8, pretty much 0.625 times 2 plus my 2 inches. So 3 1/4 is how, like a 3 1/4 square will encompass this. Seems like we stay in this realm of measurement all the time in mechanical. I'd love to push that beyond that and have to use some break lines, but I wish this middle section maybe was 10 feet long or something. Then we could do a section and a break, but for future. Let's see. And then, so that's going to capture this back plate has a diameter of 3 1/4. So it's actually technically, it is kind of stable in that, because it's a, it's a part, it's all joined together. If I do choose this surface as a front surface, it is a pretty stable part position because the diameter of this kind of matches how big of a rectangular pattern fits here. And so as these 2 points hit a table, so will this point back here. It'll kind of be like a three-legged stool, but still argue. I mean, the most stable part position would be laying one of these surfaces down flat for sure. It would just not show great detail without doing other views. So it would be kind of that's what makes it maybe a poor choice for front view is the lack of details. But our bracket design had that going on with it too from a couple weeks ago. Okay, so I do like a 3 1/4 inch rectangle to encompass this. And then in the right side view, it's going to be it's going to be some depth associated with this part, which I have as kind of 220, 2.2, but that's 2.2 plus another 0.5 here. So just watch this dimension, just where it's at. It's technically 2.2 plus a half inch. So if I need to remember that, maybe I'll clear this out. 2.2 plus 0.5. 2.7, I think, is overall what this part measures, 2.7. Okay, so I'm going to draw some information here. My front view will just go here, and I think it's only going to be 3.25 by 3.25. It's actually just a perfect square that encompasses this part in its front view. And then I'll go ahead and detail what the right side view might look like. It'll share the same height, obviously, like it always does. Maybe I'll come over here some specific, or no specific, but maybe a few inches, 4 inches. I'm about 4 inches over there. I'm gonna make this rectangle the same height, so it's gonna be 3 1/4, right? And then it is 2.7 long, so it's an odd. So really the part only is that deep. A plate and a plate and a pipe kind of in between them, or a cylinder shaped feature. Okay. And I could worry about them being perfectly spaced if I wanted to deal with one viewport, but because I'm probably going to deal with multiple viewports, I'm not going to worry about it too much. Or maybe I'll get a look at how I didn't call it the scale on this one. The rubric might call it a scale, but ignore if you're reading through the rubrics and they call it a scale that's maybe contrary to what you've used. Don't worry about that. I tend to go back and fix those wrong rubrics with the wrong scales called out, but especially when I say it's drafter's choice, I just make sure you've got a scale locked down that you chose. So that's all I'm going to worry about, knowing that I'm going to section a view and maybe take additional view across. So this will give me the work to start, I think. I can take a look on my B-size sheet, see what this is going to look like, but zoom in on this thing and what scale. A one-to-one scale is like that. I mean, I could move my view closer for sure, but I'm definitely just going to worry about multiple viewports at this point. I'm just going to worry about the drawing, and then I'll copy and paste it where I need to if I need to when I need to detail it. So I do feel like it's probably going to fit on a one-to-one scale here. I'll lock that back down, but I'm not going to worry too much yet. Okay, I just got an idea. Let's draw this thing out. Um, let's see. I'm gonna offset this by that 5/8. So if I'm gonna do my offset command of this 0.625 is what I'm gonna do, because that's just gonna offset this rectangle like this. What I'm doing is I'm just creating like a point where that 2 by 2 square lives, so that this is now 2 by 2. Like I said, you can proceed any way. The way I draw does not have to be the way you see the geometry, so don't think that you have to draw my way. A lot of times the way you guys see geometry is maybe clearer than sometimes I do. So yeah, I offset that. I drew mine as a rectangle that I could just offset with a single selection. And then this ends up being 2 by 2 because what I'm drawing is kind of what this potential, like it's just a construction square, but it's right here 2 by 2. And it's only because I'm gonna base these radiuses and these holes kind of off the same, like they're concentric here. So I'm able to draw both of these features now, and I'll probably just draw one and then pattern it around. Um, but you could draw them all individually too. But I think I'm going to draw like one set of circles, pattern it around, chop them maybe, and then I might pop these in individually between that kind of arrayed pattern maybe. And then I probably have to break the array to be able to chop them up. So I'm just going to do an array, kind of use it, and then I might explode my array and chop my features. And yeah, yeah. But I'm definitely just going to start with the outside profile plus the holes of this X plate. So I'll probably do this as visible line work. And so I'll just need to make sure my hole size. Well, I had a 5/8 radius for sure. And the hole diameter, I think I'll call that right here. 8 by 5, 8 by ½ inch, 0.5. So that's 1, 2, 3, 4 back holes and 4 front holes. 8 of them all at a ½ inch. Okay. And 5/8 is and then these are 3/4, the tangent to tangent. Okay. So I think we can do this. Yes. So what I've got is I'll just start over here. I could start in any corner, but this is my concentric center. So this is where my ½ inch holes are. That's a ½ inch uh, diameter circle, ½ inch diameter circle, and then I had a 5/8 radius, right? You could actually pull this out to there. That should be 5/8 by the way I built my construction geometry. So I don't have to always input the data if I have construction geometry that I've already placed that is the size. That's right. I can see it show up on my screen. I could pattern this around 4 times. So I think I'll array that rectangularly. These objects. And let's see if I can control that now. I just need 2 columns. And then I only need them to be 2 inches apart. So they're slightly not 2 inches. I only need 2 rows, right? And then I just need to flip that the other direction. So do I grip that and flip it? This one is a rectangular array. But you could have done a polar array around the center point, right? You could have done that and just done a polar array. I did a rectangular array. And just so you know, you've got like a grip on that array. I think it seems like it always populates above you as your rows like populate above you. So you can just grab, there is like a triangular grip that you can grab, then you can pull your rows the other direction is how I wanted them to be. And however I want these, I didn't see that I didn't change the in between rows is also 2 inches. And so then it goes back. Here's my grip to pull the direction, right? Yeah. So if I just pull that in that direction, like polar, like kind of like my polar alignment there, and I've got those set, that's actually calling that -2. So I could have got it to flip by saying -2. If you, it just wants to know, I guess it calls your X, my row is kind of in the X direction and positive value is above you, negative values are below you, wherever you establish your start point of your array. That's kind of different, or you can grab the grip and pull it, but think it'd be the same with your columns. If you made this a -2, it should go to your left versus your right, just based off where you started. That doesn't make sense by coordinate point necessarily, but if I do this, I think this should spin the other direction. So if you have, I don't think we've played with rectangular array too much, and it's a little bit, I kind of get confused with it. It's a little bit different than inventor's array, and I kind of forget, but kind of the same. This did not pop up. Let's see here. I will close mine. Or maybe I'll escape mine and see what didn't happen. I'll undo my, I don't want to print yet, cancel. So I'll undo that, undo my array. So I had my geometry, I picked rectangular array, and it won't pop up until you pick things to array, right? It wants to know which objects, which I selected my objects. And then I enter or right click, and then it immediately pops up once you've selected geometry. Yep. I hope. So I'm just manipulating those columns and rows boxes. Not going to do any levels. This would probably be 3D. Yeah. So we can array in 3D. I guess I've got this associative, yes. But I'm really going to explode this because I think I've got to manipulate this geometry. Uh, and I need to build, so this is just the outer radius and the whole, and then I got to have the tangent to tangent, which my note kind of helped me know which, that this is a, these outside radius features of that X plate are tangent to tangent radiuses. And they're 3/4. So I'm just going to use that. I'll decide if I need to explode this once I try to trim it here. But um, oh, my tangent to tangent circle, a tangent to tangent radius is what I want because what I've got to work with is this. I want these radiuses in here, and they are a 3/4 inch radius, 0.75, and there's four of them, and they're tangent to tangent to what I've got. So I can choose tangent to tangent circle, tangent to tangent radius circle, and then it just wants to know which tangents first, right? So I'll just pick this. I could pick any of them. So that one I want it to be tangent. This one I want it to be tangent. And then the radius I want it to be 7.5, like that. And technically I could array that around. I could do a polar array to get that around. I mean, I could trim, if I go to trim this, it won't let you trim. I don't think it'll let you trim stuff that is locked into an array. So it's no big deal. I could have put this in there. Well, I couldn't really put that until I had these to go tangent tangent to. So I think I will just array these around like a polar array of this one. So I'm in polar array now. That one, enter, and center point of array. So I see even if you're doing a polar array, the ribbon menu doesn't come up until you choose a center point. I'm going to use this geometric center here. Uh, that's what and that's definitely a grip that you have to make sure you have toggled on geometric center. And then I only need four of these. That's why my doesn't quite look right to me, but it'll adjust the the degrees of those automatically. If I'm considering it to be in a full 360 pattern and I change four, it automatically changes the in between to be 90 degrees, which is what I want. I'm going to close this. And so we're making a mandala, it looks like to me. That's pretty cool. Make a tie-dye pattern. Excellent. No, we're going to trim this up. So I think I will explode these arrays. So I'm just going to select that to explode and this array pattern to explode. And now these are all individual. And I feel like I can trim these. So I'll probably trim these. I'll just turn off my construction layer for just a second because it adds some extra trim, right? We just want to get rid of this, get rid of this, get rid of this, strike through here. And then this one gets cut out. So I like to do my scissor path sometimes like that. Sweet. That's the X plate. Awesome. That's at least what's, oh yeah, we gotta do more. Yeah. That's at least the outer perimeter. Yeah, let's do the counter bore. We'll turn that back on then so I can find my geometric center. It's a centered counter bore. I don't know if it's explicitly does show a center line through here going down through the bore, but yes. So that counter bore, yeah, has a 3/4 inch through, and then the counter bore is an inch and a quarter, and then it's 0.2 deep, which I'll need to know in the right side view more than the front view here. I just need to know 3/4 and 1 and 1/4. So I'll put those two circles in here. If you want to use your diameter, you can. This is a 1 1/4 and a 3/4. Well, I'm in radius now. If you ever go back in, so you have to do 1/2 3/4 3/8. That's 0.375. So I've got my 3/4 inch diameter circle, and I've got my 1 1/4 inch diameter circle for the counterboard. Yeah, now we're looking. At least the visible line stuff is done. Now let's work on the what would be hidden in this view. Um, Let me see what the diameter of the thing is that goes from here to the other plate. So I think it's the 1 1/4 inch. Let me see. This one points out it is an 1 1/4 inch diameter. So technically my outer bore here is going to carry, it's going to be in alignment. So my largest counter bore size is actually going to be the visible line for that is actually going to also overlap with the outer, which we call the OD, the outer diameter of this particular cylindrical feature that's in between the two, that's spanning in between the two parts. So I don't really have to draw any additional information. There'll be a hidden line buried underneath that, but I'm not going to draw it. So same diameter going across. So let me just put the plate in there then at least. I'll start with the plate and then I'll do the whole pattern. So the plate is 3 1/4 inch diameter, 3 1/4 inch diameter, and then I've got the same size of holes and they're on a 90 degree. And then these I need to put in before Christ was born. No, actually, what does BC stand for? You guys know?
Forward and
Oh, that would be close. It's like bolt circle. Bolt circle is like a shorthand note that you'll see on here. And whether that's a bolt that goes in there or not, they just call hole patterns out as like bolt circle patterns. And it doesn't necessarily mean they have to be for a bolt. It just means that that is a diameter that those holes are based off of, like their patterning. So their centers are on a 2 1/4 inch from center out is their, and then they're on 90 degrees. Like I have down here that this is the 4 times 90 degrees apart from each other. So that's how you'd be able to locate those is use that bolt circle, they call it. Sometimes there's another one, well, yeah, I can't remember what else they use besides bolt circle, but they add one more letter to it sometimes. But BC is what I'd see with no periods or anything. But yeah. And now they've changed that, huh? Because now in time wise, it's BCE, which is like before Common Era, right? And AD is now CE, which is like Common Era. Is that right? Yeah, I think so. BCE is now, those are for the, you know, so we get the religion out of my time or something. I don't know. Has nothing to do with this. So that's also useless information. This is bolt circle, bolt circle. So I'm gonna keep track of that, but I've got a 3 1/4, got the holes, which are the same 1/2 inch holes, 90 degrees on a 2 1/4 inch bolt circle. Okay, let's do this. I'll just do it as visible line work. I think I will. It's gonna get a little bit busy, but that's all right. Let's do my center diameter for the actual overall plate. I should just be able to pull it up to. That's why working from a diameter circle is so kind of weird. Like working from a radius circle, as long as I've drawn my construction material, I kind of maybe prefer it, right? Because it comes out to here, and that is this should be a 3 1/4 inch diameter circle just by pulling it to my my plane that I established, my projection plane, I guess. 3¼ inch diameter is correct. So that's that plate that I would see behind it. Of course, I won't be able to see it like that. What I love about this drawing is though, is that some of it I'll see, it'll stick out from the X plate, then some of it will become hidden, and then it'll just show itself in the holes right here as like visible line again, right? So I love that that we're gonna break the heck out of this thing uh in order to kind of detail it right. It'll be like visible and hidden kind of intermittently as it shows itself and then goes behind something. So I like that. Um, I might experiment with that just a minute. I can't remember if I can break this at a point, and I don't know if we've used this yet. I feel like in past I've used this more, but on my modify palette in these buried commands that I use, I use join quite a bit here, or I use the send to back, bring to front. And of course, if you remember the key commands, that's fine. But I also like these two a lot. So this one is break at a point. If I hover over it, I was hoping it was going to tell me that. It's break at a point. So so say for example, if I choose that, I'll do it how I'm hoping it can break my circle. I don't know if it always can though. We'll see. I think sometimes circular some geometry will allow you to break it, but it wants me to select the object. Okay, this one. And then yes, I think you should, as long as your O snaps are on. I can actually pick to break up this circle at a point. And so I can actually break my circles or any kind of geometry using break at a point as long as I have the point selection available. Break at a point. I can pick and break this circle up and so that I can change the line types in different segmented areas, right? That's how I'm going to do this. There's other ways to do this too. You can just draw another circle, chop it all up, use that one, and then do another one and on the other layer. Yes, I'm going to use my one and change the layers as I break it. So maybe I'll try that while I'm in the command here before and so it says I can break at a point there. And then if I break it, I'm going to repeat break at a point to this object here. I'm going to break it here at this intersection point. Now, what I should have is I should have this. I don't know if it will do it though. I think circles are kind of weird. Yeah, I don't think it actually did break. It acted like it would, but it didn't. And nothing. And so I think circles retain their geometry like that, maybe, to where you can't change that. So I might have to actually draw another one and chop it up. Some geometry you can do this though. I think once it's a radius, it will allow me to do different breaks in it. Yeah, so maybe potentially. But what I need to break up is the circle. So I might have to end up pulling, I don't know. That one's my visible circle. What it would change here is I would trim it out around here. So let me do this. I'll do it. Maybe I'll do a trim. I'll trim if I trim these out, so that would actually work for me good though too, right? Like then I would leave that one as visible anyway. So maybe I'll trim these up real quick. Go into my trim command. I'm trimming away what I'm trimming away is the what will become hidden, which is this stuff. That becomes hidden. It already starts to look better once I actually trim it out. I'll keep my eye on break at a point. The other one that I was going to show, that's the one I use a lot. The break at a point and create a gap is one I don't use as much, but it'll actually separate the two segments once I break them. Um, I'll come back to this. I feel like I do use it a lot. I just haven't used it on any drawings yet for any reason. Usually I'm doing this where I've got some geometry that I want to break up and change which layer half the geometry is on or whatever. But so that's the visible line work. Maybe I will just pull a hidden line. I'm kind of just being a completist a little bit on this view, whether that's right or wrong. Maybe I should wait and come back to my headline work, but I think I'm going to just uh, finish this before I forget to put it in. Then you would have like some hidden line work that would show like this. What's that? Oh yeah, maybe so, huh? Yeah. You have to hit that double tap that, huh? Yeah. I agree. I do like a lot of times when I go to trimming, I do sometimes simplify my drawing like that and eliminate how many clicks you might have to do. So yeah, I guess this will work this way. I was thinking I could break that at a point, but I do remember that um, circles give me a hard time sometimes. They don't like to break like that. And then this one I don't need. So that's actually a better representation of what's going on. It's kind of hidden. It shows itself. It's hidden. Now let me put it in circles. I think they have the same going on with them. So I'll probably put in one circle and maybe array it around and then maybe break it or something, but or explode it. And this is kind of a different drawing where I guess I do more work in one view than I before I start projecting, but I am going to project this information across. I'm not just going to like draw it independently. I'm definitely going to project over, use that mostly for alignment. You know, I did catch a few people out of alignment in the last couple assignments I've done. Yeah. I usually try to keep them, if I'm going to do it in my model space, I keep my views in alignment so that I can project from them, whether it's top down to right side or vice versa. When it comes over to putting it on my drawing, I'm like, let me talk through this just a little bit. When it comes over to putting it on my drawing, I might be less, I still keep it in orthographic alignment, but maybe I don't keep it so that top and right side are maybe in total alignment. Like I don't worry about placing this because sometimes I've got different viewports where I'm trying to actually mess up that space because it's too big or whatever, right? And so, but I still keep it like in alignment in the Y direction and in the X direction. So I keep those views in alignment, whether or not top to right is actually in projectionability alignment. I don't worry about that. So maybe that's a little confusing. And so when I've told some people, hey, you're out of alignment, it's usually that I'm telling you you're out of alignment in your model space to where projection won't even work for you. And then sometimes I've seen some people, and then you have to be careful, right? When if you have multiple viewports and I build another construction layer with it, just a couple, like almost an XY line that I can align my views because I still want my views in different viewports to be orthographically aligned here. Just, I can break the rule and not worry about the top to right side alignment. And maybe that's a little confusing, and maybe it's a little lazy on my behalf, but that's how That's how it'll work. And that's kind of how 3D programs work. They're not going to make me pull away some distance. Once I drop one view and then I'm going to grab another view from if I've drawn something in 3D, it's going to allow me to place that view however far away from that other view I need. And what I'm doing is creating space for dimensioning. So it's not like it's like my use of orthographic projection is already over at that point. I'm just trying to like still keep them in view, but be able to dimension them. And so I'm not worried about projecting from them. I don't know. I think I'm over explaining that. You get it. Okay. Holes. We got to go back to holes here. I'll just do them as visible. I can't remember how these ones show up for sure. I need a circle pattern though here. So whether I keep this one here or not, I think I will. I'm on my center circle. I want to do my bolt circle, which is 2¼ right? I think I still have that in my mind. So if I want to do diameter from the center here, this is the bolt circle pattern. It's 2¼ I believe, diameter. Is that right? I think it is. 2¼ yes. And then yeah, that's I actually just put in this. I put in uh this polar center line. And then they are just on that in the perfect X and Y orientation. And they are 1/2 inch holes. Okay. Yeah. So I will put on my visible line work now. And they're right here. They're going to be, and I could draw I have these snaps, which are quadrants here, or midpoint is where I want this to be. And I could pull or snap down, or I mean, I'm just cursoring down here from being in alignment here until I hit here. That is the quadrant though, also on that. So these are going to be based off that quadrant and they are 1/2 inch holes. I've got my radius command, so that's a 1/4 inch radius. So that one will show itself there, and then it'll be hidden line here where the X plate kind of covers it. So it's also another broken one that I might have to draw twice. So maybe I'll do that both times here, and then I'll just pat and then I'll array around its little it's the weird features, since it's a circle with two different line types. So I think I'll trim this one real quick. I'll turn off my construction layer again. Oh yeah. I just actually ended up putting it on the quadrant, but yeah. All I did was cursor down until I actually intersected this bolt circle on its quadrant. But you would even have to really cursor anything. You could just like go to that circle, find its quadrant. Yeah, this particular and that's yeah, go ahead.
Any circle plate or on line with the,
This one, these ones here,
no, not on the X plate.
this one.
I think those are online with
Oh yeah, you could. Yeah, that's not a bad idea too. Here, there's probably going to be a need for if I'm on my center layer here, and went over to center mark, and actually put my center mark as probably this one. Yeah, yeah, I like that. If I do those, I like to throw this not at 0.5, but I like to do this before I forget as well. Yeah, good point. Yes, and that's actually that creates the intersection point here, huh? Yes, between X and Y. And you would want this center mark on here anyway. Like this one I probably will leave on here too, even though it is more information that's on that back plate. I'll probably still leave it on this front view. It's technically kind of like a hidden center line, but hidden center lines aren't really hidden anyway. They show through like this. It'll definitely be if I take a section of that to expose that plate, so that I can look on it dead on, then I'll definitely have that bolt circle. I can't remember for the last time I drew this if I left this on this front view or not, but I'm going to use it to my yes, because this is where the next one goes. But I think what I'll do is I'll chop this up right now and turn it into right. It's only going to be visible here, and this is all going to be hidden line work. So I think I'll chop that, and then I'll draw another circle that's hidden line, same diameter, which I can just snap there and snap there, and then I'll trim out the hidden line section or this, yeah, so it looks like that. So now I've got a circle that's kind of in segmented. That's actually my favorite part of this is that. I don't know why. Just the details and breaking up. And then I'm gonna polar array this around, I think. So I'm gonna use an array for these two around this center here, and then change that to four items. Maybe that's a good way to close that out. That's probably about the end of actually that view. That's kind of one, this is a particular drawing where we almost finish one view before I really project anything over. Yeah, I think so. I like that. I'll turn back on my construction layer. Now I'm ready to project some of this information over, try to make sense out of it. Um, yeah. A couple things I might do if I just look at this real quick is now if I'm looking at it this way, I definitely have, I'll just double check myself. That should be 2.7. That's what I did, 2.7 overall. And then these particular thicknesses here, and in this view, it might be their depths of these plates. Depth are half inch. So I might just draw those, and they'll appear as just rectangles. I'm not going to put in probably their where the radius tangent to tangent kind of breaks up here. Like I'm probably just going to make this as a smooth contour. And so I'm just going to show these plates as almost just rectangles. Like this cylindrical shaped part is going to look like a rectangle in its side view. So is this front one, even though it's an X shape, it'll just look like a rectangle. So I might just draw those in real quick with visible line work because I don't really need those to project over. They're just like, oh, I'm going to do them as a rectangle maybe. I might have to explode them and cut them, but it's just 0.5. And then I'll just snap it down here, or I'll put in that it's 3.25 in the other direction. Yeah. Oh, maybe I'll just mirror that over to this object here. I'll just mirror it across this center line here. No, they're both the same thickness here, and then they span 2.7. Yep, just a little double check. Now I can project across these and kind of make sense out of maybe what's going through here. For sure, the holes will be. So I'm not, this isn't a section view that I'm drawing. This is just going to be a right side view. So, um, I think there's an argument that I could section this, but I still think I still wouldn't have the details of the back plate. If I thought, if I thought somebody said, hey, why don't I just section this and be done? I'm like, well, you still wouldn't get the definition of this plate until you section it and look at it. Either look at it from left or look at it from right. I think you have two options. Definitely you don't need it on the X plate. You've exposed it all. It's right to the front view. It's a little bit busy because it's got hidden line work going with it, but it is a clear visible line drawing for the front view of the X plate. It's just that I can't see that one well. Yeah. Anyway, let's continue on. For sure what I need to project across here though is that information. Thinking of this bore going through. So maybe I'll think of this. This is the counter bore. So the counter bore only goes through the front plate and it only goes to a depth of 0.2, I think. I'll just draw it all the way through the front plate just so I have it there. But I'm not going to take it clear to the back plate because it's not features it's associated with the other plate, just the front X plate. And the inner bore goes all the way through the part. It says through all, so I'll take it through. Do I feel like that's not square, or is it just my eyeballs are not square? Sorry. Did it look square? It kind of, to me, it looked. I have to tell you, when I got my glasses, I've had them for a couple of years now, but everything looked crooked. It was hard to, I mean, because my last optometrist said you had a little stigmatism here, so I changed your prescription. Oh my gosh, everything was crooked for a while. But then he's like, yeah, that's because your eyes overcompensated for that. And then eventually he was right. It took like a few weeks. I'm like, oh, everything's straight again. Man, I think it had to be hard on my eyes to try to strain that. Anyway, weird. But now I can't wear those glasses when I look up close. So then he's like, yeah, you need bifocals. I'm like, oh, I'm really old. Anyway, it's okay. So I haven't bought them yet, of course, because then I won't. 'Cause I'm still young. As long as I don't have bifocals, I'm young. No, not really.
Hey, Matt,
Yeah,
can't you use the outer counselor construction line?
I need it. The overall width, right?
I was gonna say like the in between.
Yes, you just reminded me that I actually do need it. So where I stopped it, yep. I I I totally agree. I just got to remember that it's also the counter bore, and then it's actually what spans in between, and yeah, you're right, totally right. I did need it all the way across. I like that. And then the hole. So I guess I can kind of make sense out of this, and then I can throw the holes over before it gets too busy. So maybe I'll do some visible line work here. But you're right. That'll definitely represent the piece in between the two from plate to plate like this. Yes. And the inner bore will become hidden in this. And then what I'm reading for the depth is this. This is a depth of zero point 0.2. That means from this front surface to where this ends is just zero point 0.2 in dimension right there. So I can draw that in here too, going to the same line, but only going zero point 0.2, and then back up. This is gonna be visible, and this is gonna be hidden. So I should have done it on the hidden layer, but I'll just continue until I finish here, there to there. And now I'll switch over and maybe make this hidden line work. I'll just switch one right here this way. Sometimes how I do it. Hidden. Then I'll just match those properties of the one that I changed. So that one will be hidden. That's the bore. Then these inner bores I haven't done yet. So let me draw those. I'll just draw them correct layer, hidden layer. It's going to go from here all the way through the plate, though, I think, like this. Repeat line from here all the way through. So now it kind of looks like a counter bore that we've seen and drawn a few times now. Now I think I'm ready for hole details. I think so. Yeah. That's going to become, yeah, that'll stay visible. That'll stay visible. Yeah, I think that's correct. Right here. This is 0.2. Yeah. And given as that size of that counter bore was to a depth of zero point 0.2. And this is a right side view, so this is considered depth here, right? Top would have had depth and it would have transferred down, but this is still, I still consider this, width, height, and depth. So let's see. Holes. I think I just want to construct some holes over and through that'll be all hidden. All the holes I think will be hidden essentially. I'm not going to worry about the radius features and how they change. I'm gonna just leave those as without any visible line work or anything. So yeah, just the holes I think to project over. So I really only have to project over this side. I want to be on its quadrant, the very top point here. And this is just through the front X plate here, so I think I will stop this one there. And so I'll worry about the ones going through the X plate first, back on its quadrant and across, and I should have the lower plate should be the same, this one here. And of course, those two are in alignment, so I only need to take over one side. So that'll be the holes for the X plate, and I can just draw those in before I get confused and do the other holes across. Sometimes I work systematically like this if I feel like I'm going to get busy and forget what is what, and then I just kind of finish it off and then I can move on. But that's the hole through the X plate that would be hidden, and two of them would be in alignment. So it really is doing double duty, picking up both sets of holes with single lines. Okay. And now the other one I'm going to project over is for the other plate, these particular holes here. So really I'll have this one, and this one that I got to project across. I've got like this one will go all the way through to this plate. And this one. And then for sure the one that's just opposite it down here. I could mirror that over though. If you want to use your mirror command, you could do a lot of that too. Um, of course, I do this mostly for alignment, and I do this mostly because if I got to fix this, I probably come back to this view to fix stuff. Uh, I should set us up for failure sometimes, so we have to do like a brutal fix because it is pretty hard to fix stuff. Um, and then this one is the other one I need to take through here. It's gonna show up as hidden line, yeah, because it's going to be in the plate before I even, as I'm looking through it. So I'm going to see the hidden lines of this before I ever see the hidden features of this or the visible features, really. So it's just my eyes are going to see this, and that one will be in alignment with it. So yeah, I think I'm thinking right. I know it's getting pretty busy here, but we'll change all these to hidden lines, or I mean, we'll draw over them, trace over them with hidden. So this one. I mean, I could mirror that across. Maybe I'll just I'll kind of be lazy here and I'll mirror these ones across. This is the other hole, right? I'm just going to make sure that this is the hole. And then those three lines, I'm just going to mirror those over. So it's just this line, and this one. And then they're going to mirror through the center here. I'm not going to erase them. So that's just me just applying the other three. Okay, so I think that's pretty well the hidden line work. I think so. I'm going to turn off my construction work, take a look at it. Does it look like that? Am I missing anything else? Missing a bunch of center lines, so I'll do that. Jump over to my center layer and start. So I like to use the center line command as long as you're picking like the right set of pairs that because it'll place it right in between the two, right? So and it'll be based off their length as well. So I'm gonna just choose this, but I'm gonna pull it through longer through the entire object here. And then I would extend these the 1/4 inch. So that one is definitely a good through bore. And then all these holes are going to have a center line through them. So I'll do that as well. And maybe I'll just do one and copy and paste them. That's the same thickness of plates. So maybe I'll come in here and adjust this one to be the right extension length. And then I'll copy, maybe I'll just do a copy on these. Copy those, copy this one. I'm going to select it from right here where it intersects right there. And I'll just place it. I don't need another one there. That one's in alignment with the main center bore. So I need one here. I can't work that though. That's not going to work for me. Sorry, it's not a big deal though. I don't really have a center line, or I don't have a center mark without making one to base that off of. So it's a nice thought, but this is pretty easy though. I only need 4 of them. If I needed more, maybe I could have done. It's not really a good rectangular pattern there either, just because they're not in alignment, but And then I can at least get their extensions matching by using a match properties. That's one thing that will carry through a match properties is the extension is one that I like that. Okay. So that's pretty good. That's all you'd be able to see from the right side view, I think. I think that would be so it's mostly hidden line work, right? It does show the nature of this view is mostly I could dimension to the center lines of these though. I have center line dimensioning I could do, but I think in order to get a view of the last part and so I can just see it with all of its visible line work would be the reason for a section view here. But I think there's an argument here that I don't have to do a section view. I could do a I could do a viewing plane as well. And so maybe I'll choose to do that this way because we did a section before. And a section I might just come in here and it wouldn't really matter. Like when you're sectioning, it doesn't have to be like perfectly in between something. Like, I mean, in this situation, I probably could make my if I go to my plane. So let me I'll just draw my options that I feel like I have here. And then usually I draw these as a polyline. And it's mostly for the arrowhead, but this and sometimes I'll just cursor up this way. And what we like is to like cut clear through, right? But this is me coming off the midpoint that I have right here. That's not, and that's a nice to have. I mean, that's nice because it works well for this particular. Like I could totally establish. Um, I turn these back about a half inch is what I use, and then generally I'll just span no particular length, just and I will adjust these after I've dimensioned generally so that they're not overdrawn like way beyond that I need to. But this would be a legit place to take a section. However, it wouldn't matter to me, just so you know, with sectioning, it doesn't matter if this is like slightly more towards that plate or slightly more towards that. In the case of this being like really long or whatever, I would probably actually section it closer to the plate that I'm trying to expose. And and of course I turned that the wrong way, just so you know. If I was actually wanting to look at the other plate, I wouldn't be going this direction. I'd be going this direction. Um, and maybe I said about a half an inch, but I'd actually be pointing back and looking at that direction. And then I'm probably going to put my section view here. So I'm going to point that way and put my section view here. I think that's why the arrows are really really critical, right? Because whichever side my view is placed on can be confusing. Somebody if they just saw me draw the circle over here, they think I'm looking the other direction, but my plane cutting plane arrows will tell me no, that when I'm looking at that section view, I'm looking this direction, even if it feels like I should be. Does that make sense? Like technically I'm kind of looking right, and you might think that I would have to place the view over here kind of like it would be if almost like a left side view because I'm looking from left to right. And but that's not the case. I can actually draw that over here. I can even draw it anywhere in my model space. I'm probably going to use projection to draw it somewhat. So I'm going to keep it in orthographic alignment and use projection to continue to draw it over here. And my cutting plane arrows are saying, hey, that's why it's critical to like label the heading on the section view and label the section views like point A to point A or point B to point B, whichever one we're looking at. But yeah, so this would be a legit way to do this. And maybe I'll just proceed to do it this way, and it'll be just a section view where I'm looking from left to right at the round plate. Yeah, so I say from here to there is not determined yet. I just make sure that I clearly go through everything. So I like to so sometimes I'm like 3/4 of an inch. If I'm actually putting in a dimension, sometimes it'll be like 3/4 inch or 1 inch, just so I get it like beyond what I'm sectioning. And then and then I will come in and I'll tuck that in once I have dimensions and everything. I'll just take one last look at my cutting plane to make sure when I first placed it, it's not overextending. And so I can I'll bring it closer, but I still want it to like be clear of any dimensions and for sure clear of the part. Like the most critical thing is that it clears the part completely, or however you want to section, that it's like, this would be very bad if I had it like this and I'm showing the full view over here because technically this would be me saying I'm not sectioning clear through this whole thing. So yeah, they change. I would say that you have a lot of flexibility in your section view because you as a draft is kind of a drafter's choice. Like you're just trying to make it clear. Um, so I will keep this one going this way. I'm just going to add this little half inch to the top here. Then I might join all this up. Generally, I join my section so that I can kind of do it as a single selection and move it how I want to. This is a little bit annoying because these get grips here, right? And then, so it's this is a little bit annoying to move that. I probably will grab it by the grip to pull it in and out, but at least I think that works. Let me see. Because polylines have these other grips. Yeah, but that would work. And then we need to place an arrow on there. So maybe I'll build an arrow. We had one built. I don't know if you still, it's not in this drawing though, and you wouldn't, and your libraries are probably wiped, but we can do it again to remember how to do it. And so let's do that. Sometimes I do it now while I'm just thinking about it, so it's done and ready for me when I need it. I don't place it in here. I like to place it as an annotative object, kind of like your dimensions. So I'm going to build it and then block it. So let's see if we can remember how to do this. Like I could use any continuous layer that I have. I've been using just the visible object. Maybe the drawback of that is it's maybe the darkest and boldest on our print, but that's okay. I'm still going to do it that way. I'm going to use my visible object as a polyline. This is how we built this though. It's double the size of a normal arrow. We're still, I wish we were in a metric template, so we had to do the math on that, but it's going to be the double the size of a normal arrow, which is uh 0.125 long by 0.04 wide. So I'm going to make mine 0.08 wide by 0.25 long. Double the size. And I'm on a polyline command. Polyline, this is where I want my line to start. And then I got to do a width selection here. So I'm going to change the width. Oh yeah, I'll get there. It's going to be a 0.08 the width first. And that's the starting width. And the ending width is 0. And then the length is 0.25. I did a polyline like that. And this is how we did it the last time before. I'll do it again here just so you can remember my command sequence. I don't need to do it here again because I'm actually going to delete both of them, but this is how I actually created it is I went polyline and I want it to start here. And then normally you just go to town on a length, but if you remember you have a width, like a polyline is a super dynamic line. It can do arcs, it can do half widths, it can do lengths. I mean, like I get a lot more. Let me just compare it to a line command. If I go line and I select here, I got nothing. I can undo the line, but that's all a line can do. It's kind of bound by its line type and its line weights. And so a polyline is just a super dynamic line, and that's why I like it shows it like this. And so I'm going to start it at the same point, but I'm going to go in and select. I can either type W or I sometimes just come down to the command line and click on those boxes. And the width is going to be double the width of a normal arrow. And you probably don't have this memorized, but I always memorize that my arrow is 0.125 long, and then I can kind of do the 3-to-1 ratio. Arrows are, by the rule of drafting, 3-to-1 ratio. Their length is 3 times their width. So ours is 0.08 wide, 0.08 wide. That's the first thing it wants to know. And then I hit enter. It has 3 inputs that it wants to know. Now it wants to know, well, okay, that's great, but however long you are, what do you want the ending width to be? Because you establish like a starting width. And this is just one way to do an arrow. I'm saying 0. And then I'm saying that this has got to be 0.25 because it's double the length of my normal line, or my normal arrow, which is 0.125. So that's 1/8 of an inch. Double that is 1/4 inch or 0.25. And then that's my arrow. But it's kind of like what I call is not a smart arrow. I don't call it a dumb arrow, but it's not as smart as it could be. So I block this thing, and we'll do this, and then maybe it is a good time to actually take a break for 5 minutes or something, since we've been grinding away at this, and we got to do our section view. But I'm gonna make my block first, and we'll take a break, and I'll call this part 1, and then I'll stop this video and do another one. So let's see here. I'm going to block it. So block. The other thing I haven't showed you on block is remember this like annotate, like your home tab is just kind of, some of these are shortened palettes or the ribbon menu. They're just kind of like a quick access to them. Like your annotation tab is only just, it's pretty, I like it because it's like a quick access to what I use a lot, but the annotation tab is way more dynamic, obviously. Same way with your block palette here. It's pretty simplified. If you want to see the full block palette, go to your view or insert, sorry, go to your insert tab, which we don't use a lot. But this shows like this is actually your insert tab shows how dynamic blocks can get. So I'd mentioned that when people do like when you're modifying the when you and this we could spend a week just doing like fancy blocks, but we don't do a lot in this course, unfortunately. because I think it's a super useful tool, especially if you become a template creator of sorts or need to create your templates. So like on our ISU templates, we have the title block where it has attributes where once you play or once you go into it, you can edit the stuff. All they've done is they've essentially just drawn all that stuff out, and then they've created a block, but they've created what's called a write block. And so if you're going to create a block from the insert tab it has an expandable list here, there's a write block. So a write block is what those title blocks are. And then as you draw and make stuff, you can define those attributes here as how you actually make a line item in your block. So if you want to know the title and have it be able to change, you'd actually have like title down here. Then as we can define those attributes and say, well, I want it to say title, but then I want it to be an input where someone types in what the real title is. And so I mean, we could go into depth on here, but that's considered a write block. And and really you don't have it on the quick access menu unless you just remember it's a W block and type it in, but W block is write block. But I just wanted to point this out that we haven't spent a lot of time on this tab, but this is where you get pretty creative with your blocks, and uh, and it's a deep study. I think it is a deep study for sure. Um, the kind of block I'm going to create, I can create from just this one simple create block here, or just a regular block B for block. But create my block, and I'm going to give it a name. I'm going to call this same like we did last time, but I call it like a cutting plane. Cutting plane arrow, and it's inch maybe. Maybe I want to know that it's like in standard units or something. So I'm going to call it cutting plane arrow inch. And it might not let me do this because I might have some on mine already created that have that name. I don't know if usually it'd give you an error maybe there that you need to name it something unique. But I'm gonna start mine here. This is technically the endpoint of either one of these lines here, but it's because this line has all this width associated with it that's not selectable. But the endpoint of that line still has an endpoint, just like it does here to here. So that's it could be the endpoint to that line that I'm grabbing. But either way, that's I want it by an endpoint, maybe the one that I'm going to place it by. And then I'm going to select those objects, and it's just going to be the arrow as one. Maybe I've got to go this way. So I just get it. Yeah, there it is. That's my object. So I'm going to right click or press enter. Then I'm going to make it annotative, and that's going to help me just do the scaling for me when I go to place it in my. So I'm going to make this annotative, and then I don't think I'm going to select match block orientation to layout. I think I can do that, and then it would always be maybe in the horizontal position, but I can rotate these to be, I can use the rotate command to rotate these into a vertical arrow if I needed it, but I didn't check that. I just did this and said, okay. And then I should have that now. You should have this in your like recents on your recent blocks, or maybe it shows up here if you scroll through there. Here's my cutting plane arrow inch. I probably have other ones that maybe point the other direction. No, I don't actually have any in this. I guess because I haven't really done that yet on this particular template. I haven't even saved my drawing yet, but so what I have is I just make sure that I have it in my blocks, and then I'm going to get rid of it here. So, because it's not a smart block, so get rid of it. And then just remember to put it back on when I go to dimensioning. So I feel like it's kind of an annotation that I add when I go to dimension. So at this point, I'll just leave mine like this. I think I will do a save. Um, Save as somewhere here. It's my in class one. I haven't even pulled up my old one yet to see if we've changed much yet or not. But let's see here, auxiliary support. I'm going to call it this, but ortho. Okay, I think it's a good time to call this as part one, and I'll jump into part two, and let's take a break, 10 minutes.